name is Pat Marshall. I'm here on behalf of Engineering Tomorrow to introduce you to a really exciting brand new lab called Packaging Engineering, something that you may not have thought of, but does require quite a bit of engineering along with other disciplines. And so a little bit about me. I went to the University of Illinois and studied civil engineering. That is in Urbana-Champaign. Right after that, I went to the Peace Corps in Lesotho to build footbridges all over that country. I came back, and in the world of civil engineering, I did a variety of things such as wastewater treatment, hydraulic analysis design, roads, cut fills for neighborhoods. So civil engineering has a wide variety of applications, and so that was a lot of fun and a lot of interest to me. For the last 20 plus years, I've been working in high schools as a physics teacher, engineering, and computer science, along with coaching several things, track, rugby, robotics, and a lot of other engineering competitions. And so engineering is a passion of mine, and so I'm really excited to introduce this lab to you because it does come in to bring in a lot of different engineering ideas and aspects, but I think it's a lot of fun to do. So let's get into it. Before we get fully into it, I would like to introduce the team that helped bring this together. Jerry Dawes, myself, Palin, and Bryce all spent a lot of time trying to make this as fun and engaging as possible. And so hopefully you'll find it a worthwhile lab to get into. So what is packaging engineering? Well, even though you may think of just a package as a box with something in it, there's a lot that goes into the design of safely transporting an object from point A to point B. Some of the engineering disciplines that may be a part of it are material science, mechanical engineering, chemical, industrial, and possibly others. Other disciplines that go into this could be logistics, marketing, graphical design, environmental sustainability. These are all things that go into a company's desire to package whatever they're making and once again get it safely to wherever they want to get it to. So where do you see packaging like this? So, you may have a package right outside your front door right now, probably from a company with a starts with an A, right? And so you grab that box and you open it up and whatever you have, you're excited to get. Well, that's one packaging. The other packaging is the object itself. So what you're transporting could be a liquid, it could be a powder, it could be a food. And so the packaging that is wrapped around that object could be made of a variety of materials. And all of that is designed by engineers and product engineers and graphical engineers and marketing, all to make sure that not only is it safe to carry that object, but also is it bright? Is it colorful? Is it attractive? If somebody wants to buy your product, does yours look a little bit nicer than the other? So there's a lot of disciplines that go into packaging, not only for the safety aspect, but also how attractive is your product. Okay, so a package that many of you would be pretty familiar with is a phone. And so what I'd like to do is show you a video of a phone being unpacked from its box. And then we'll take a look at what kind of packaging went into safely transporting that phone to the user. So you'll see here that there are 4 different items we would like to highlight with this with the boxing here. First of all is the shipping box, and that's something you've seen many, many times. And so this protects the product that's inside and protects it from the outside environment. Could be rain, it could be damage, forces, all sorts of things. And so the next item that you probably noticed was packing paper. And so this cushions the item inside the box, trying to prevent it from moving around too much and safely keeping it in 1 or 2 positions if possible within that box. Now, if you go even further, the phone itself is in a package that is specifically designed for the phone. You can see that there's shapes inside that box that fit perfectly to that size phone. That prevents any movement within that box. So what you can see here is there are several layers to the packaging, and there's a lot of aspects to if you want to safely transport this object, having several different backups in terms of protection for your phone or whatever item you're transporting is a really important design consideration. So why is packaging important? Well, obviously to protect your product, and that comes in all shapes and sizes in terms of what your product is, how heavy it is, what shape it is. Safety, and that is, if you're transporting food and other items, you want to make sure that not only does the food get out of its own package, but nothing outside will get into that package. So you want to safely transport those items, whether they're liquids or solids. Marketing and sales come into play, and again, in terms of the attractiveness of your box, and are people going to want to go to the store and buy your product versus another? And then environmental sustainability. That's one that many companies are considering when it comes to not only how big of a box and what shape are they designing, but what types of materials are being used. That is a really big consideration when it comes to how they package their items. So what is the engineer's role? So you're going to be part of an engineering team. And I mentioned before, there are mechanical engineers, there are industrial engineers, chemical engineers, material science for sure. All of you are going to come together to try to come up with a design to solve a problem. In this case, the problem is, hey, I want to get my vase or my phone from point A to point B safely. How do we do that not only safely, but how do we do it economically? And so you're going to come up with a couple different designs. This is what you're going to do within the lab. As a team, you're going to come up with maybe 2, 3, or 4 different designs that are going to have maybe different aspects to it. And you're not sure right away which one is going to be good, which one maybe not so good. But that's where the next thing comes in. You're going to build your design and test. And this is the fun, creative part of this lab, is that you as a class are going to come up with some ways to test your designs to make sure that one is better than the other. And so you're going to learn by testing, and this testing could be dropping, hitting, throwing, whatever the case might be. But you're going to have to come up with some criteria that as a class you decide, okay, this box is better than this box because of A, B, or C. And so you're going to learn from these different tests and make sure that in the end you're going to come up with your best design as a team and compare that to others in your classroom. Now, there's circular economy is something that we'll allude to, and really what it comes down to is designing products that have longevity, that can be easily repaired or upgraded, so they're modular in design, but in essence also using materials that are minimizing waste and maximizing the ability to recycle. When it comes to companies wanting to, from start all the way to finish, to be able to use materials that can be integrated into the whole system over and over again, can be a very not only environmentally sustainable way of going about doing your business, but economically it can be a great advantage. So your challenge, you can see here that we have a couple of chips in front of you. So your challenge is to grab any chips. In this case, these look like Pringles, but other chips are shaped this way. And the reason why we chose a chip like this is because of the shape. You can see that all 4 edges are shaped and curved in different ways, which makes it especially challenging to try and transport safely. The materials that I want you to have in the back of your mind when you're thinking about your design are some of the things that we're going to give you, which is a 4x4x4 box, pocket sleeves, foam, corrugated cardboard, white paper, and tissue paper, along with materials to put all that stuff together, tape and glue. But hopefully you'll come up with some ideas on your own, and whatever your teacher will allow in the classroom may add to this. And so be creative in what you might think will be a good solution to this problem. So I'd like to get into a little bit about physics. And why does physics matter? Well, we need to learn a little bit about physics to make sure that we can protect your package inside that box. So as we go through these topics, just think about all the physics we're learning is really there to protect your package. And so you can see here that there, force, Newton's laws, impact, impulse, and pressure are all aspects of very similar things, but they go into your planning. They go into how you build your box and with what materials you use. So the first thing I want to make sure that you understand is mass and weight. And we're going to get into Newton's laws just a little bit here. And so mass is the amount of matter in an object. Now weight takes that mass and applies a force to it. That's the Earth pulling down on that mass. So they are very much related, but there's a little bit of difference in terms of how we treat it. So think of mass as the amount of matter in an object. There's more mass in a bowling ball than there is in a softball. But how things move around, mass plays a big role into what we have to do to make sure we move these objects around safely. So the first thing is Newton's first law of inertia. And this is something you may have heard, where objects in motion stay in motion, or objects at rest stay at rest unless a force acts on it. So simply speaking, a bowling ball isn't going to move until you push it. But a bowling ball will continue to move until you stop it. And so a bowling ball is a very massive object, all right? It's dense. And so that is hard to get going. It's also hard to stop. Conversely, a golf ball is actually fairly easy to get moving. It's also very easy to stop. And so the mass plays a role into how easily these objects are moved around, just like I said before. And think about this in terms of what you're shipping. Are you shipping a very light phone? Or are you shipping something a little heavier, like a heavy, dense vase or electronics and things like that? So what you're shipping plays a role into your design. So keep that in mind. Let's take a look at these two pictures here. You can see here on the left that you see a rider of a motorcycle flying through the air. Now, I'll remind you that objects in motion stay in motion. So this rider was on the motorcycle. Now, objects are in motion unless a force acts on it. Now, those tires stopped that motorcycle. Sadly, it did not stop the rider. Now, we're going to assume this rider is safe and sound considering all the safety bodysuit they have on, but you can see here objects in motion stay in motion. The same thing happens on the right, and this is especially applicable to what you're going to be doing in this lab. Take a look at this big stone in the back of this truck. The truck's driving along, everybody's moving along together. Now, you apply the brakes. The brakes stop the tires grip the road, and the road stops the truck. But what's inside of that truck continues to move, or at least tries to continue to move. And if you don't have something that safely stops it within the truck, then it'll do what you see there and slam into the back of that cab. So that's a very important thing. Your package has objects in it. You can stop the box, but think about what's stopping the object in the box. So I have a question for you that I'd like you to think about. Let's say you have two boxes that are in front of you, identical in size. You don't know what's in either. And so you don't have any measuring equipment, you don't have any scales, nothing in front of you. What would you do to each box to figure out which one has more mass inside of it? Think about that for a moment. Well, some of you may have thought of shake each box. And if so, I think that would be a good way of doing it. Obviously, you would do it in such a way that you don't want to break what's inside, but how easily that box is moved around and moved side to side will indicate to you how massive that object is. And so that's one way of deciding. And that's a law of inertia. Objects at rest stay at rest unless you start applying a force to it. Now, along with Newton's first law is Newton's second law. And the reason why I talk about this is because your box, even though you consider it stationary on a truck, is being moved, picked up and dropped, picked up and moved, picked up and slid, all sorts of stuff. So it's being accelerated all the time. And so it takes a force to do that. Once again, when you apply a force to your box, what's going on inside when you change those speeds, when you speed it up and when you slow it down? That all plays a big role into what's going on. And so once again, what you're shipping is important. You know, is it lightweight like a golf ball or is it heavy like a bowling ball? Let's do an example. Let's say you have a box in a truck and the truck turns and the box slides to one side and bumps into the inside of the truck. So the truck stops the box with a certain amount of force. But what's inside your box wants to continue moving. So the box itself stops the object inside the box. That's a lot of saying box there. But you get the idea that the truck stops the box stops the object. Okay, that's great. But how the force was applied plays a huge role into whether your object was stopped safely or whether it might break. So impulse and momentum is something that I want to take a brief look at because that plays a role. Now, momentum and impulse are very, very related to F equals ma, but it's a different way of looking at the same type of movement. So momentum is mass times velocity. So you have an object with a certain amount of mass moving with a certain amount of velocity that has momentum. Think about a wagon that is empty rolling towards you, whereas a wagon full of 3 kids rolling towards you. You know you got to brace for the one with 3 kids in it because it has more momentum. Now that F times T is something we call impulse. And that little f there is called impact. And then T is time. So there are 2 factors that go into stopping something with a momentum. How much force and how long are you applying that force? So what I'd like you to take a look at is this video of 2 young men that are tossing a water balloon back and forth. And you're going to see that they were very successful for a little while until the very end.
I'm so nervous this is gonna get hot. Oh!
How have you guys not broken it yet?
No!
Oh my gosh, they're like at the fence right now. Oh my goodness, how? He caught it, they're literally at the fences, guys. This is insane. Oh, he's so...
If we look at impulse and momentum and we look at this water balloon toss, the absorbing and cushioning the balloon is the key thing here, right? That's how you would describe catching it. And if you've ever played water balloon toss, you know that there are certain ways you can catch it to be safe. And if you look at the successful catch, you can see that the young man in the blue shirt actually reached up and started catching the balloon, but took a little longer to bring it to rest. That's a small T. And so, or that's a large T, I should say. And then you apply a small force over that large time. That stops the water balloon, but does it safely. Now, the unsuccessful was the catch was the young man in the hoodie who tried to catch it very quickly. That is, he did it in a very short amount of time, but had to apply a lot of force to do so. Okay, so you're probably wondering, well, how does this apply to packaging? Well, think about this. You can stop an egg by just holding your hand out, and that stops the egg. The egg will probably break. But if you catch it, cushion it, then you can stop that egg safely. So what you do inside your package plays a big role into whether you're going to damage your object, in this case a chip, or not. Now the final thing I want to introduce to you is force and pressure. Now you might think, well, how does this play a role? Well, the heavy objects, have weight and force, and they push against the sides of the box. So the size of your box plays a role, and also like when boxes are stacked on top of it, how does your box hold up? The bigger the box, the more susceptible it is to collapse. So force divided by area will give you pressure. So how heavy the object is what we consider to be force. The area underneath that object is going to contribute to how much pressure it's exerting on the box itself. So take a look at an example I have here. If you put 2 feet on a scale and you weigh 160 pounds, both feet are equally holding up your weight. And so you have the area under both feet are supporting you. And so let's say that comes out to be 160 pounds divided by the area is 3.0 PSI. Now, if you ever see PSI, you'll know, hopefully you know that that's pounds per square inch. There are many other ways to express pressure. This is a very common one. Now, what if you lift up 1 foot? Now, the idea is that all of your weight is now on 1 foot. So the area, instead of being 2 feet, is now 1 foot. And so that area gets cut in half, and so your pressure increases. And so that will come to play in different ways in your design. So think about what object are you shipping and how much pressure it's exerting on the side walls of your box. One last aspect of pressure, you can see here that if you hold a pin in between your forefinger and your thumb is going to feel a lot of, it's not going to feel very good. And the reason for that is your forefinger feels all right because it's pressing down on a wide area. So the same amount of force over a wide area that's up top exerts a low amount of pressure on your finger. Whereas your thumb, there's a little point that's pressing on your thumb. So the area is very tiny. And so that same force divided by that small area exerts a lot of pressure on your thumb. So that's why that would be pretty painful. So how does this play a role? Well, Once again, when your object is sliding around and you're providing a certain amount of cushioning, your cushioning is really the impulse that's stopping the object from moving around, and pressure also plays a role. Are you stopping the object with something very pointy or something very, wide and catching it? So how you do something is just as important as actually accomplishing that task, such as applying a force to an object and stopping it from moving around. The last thing I'll mention here is, in terms of physics, is a concept check. So we have two cars here, A and B. One will roll into a pile of hay and one rolls into a brick wall. Now, my question to you is, which would be safer to be in? I don't think it'll take too much time for you to realize that rolling into a pile of hay would be a little more desirable. Now, I want you to consider why that is, though. Both objects have the same mass, the cars are the same mass, and they're moving at the same speed or velocity. So the momentum is the same. Now, just by instinct that the hay is going to be better for you, but here's why. Once again, it takes longer for you to stop the car, which means you can apply a small amount of force over that time. The brick wall stops you very quickly and does it with a lot of force. So it's not just what you do, but how you do it that makes a big difference. So aside from the physics and engineering of your box, we want to make sure that you have some fun with this in terms of branding. You can paint it, you can decorate it, you can make an attractive box. So that goes into a big role because, if you're an attractive box, people may want to buy your box better, but also the idea is that, it should be a safe transport for whatever object is in that box. So there are other factors that come into play when it comes to packaging, such as marketing and economics. So once again, your challenge is to safely build a box that can safely transport a Pringle or a chip under a variety of tests. And these are tests that you're going to design. I think that's the fun part of this lab, is that you get to design what you do. Do you drop it? Do you throw it against the wall? Do you hit it with a baseball bat? What are you going to do? But the key thing is, as a class, you need to decide to do something that is both repeatable and equitable. That is something that can be done to everybody's box and can be something that is measurable. So make sure that as a class you decide what that is and what constitutes a successful test in terms of results. Here's a reminder, a little bit of the materials that you can use, the cardboard and the white paper and tissue paper. But don't forget that you can hopefully bring in some other items if you get creative and try something a little different. All of these ideas may be running through your head in terms of, what kind of box are you going to build? How big is the box? What are you going to put in the box? How are you going to safely do it? Are you going to fill it with egg yolk? Probably not a good idea, right? Jello, no, still probably a very messy idea. But draw your designs. Your engineering notebook is your key to not only success now, but also as an engineering team. If you were to look back on what you've done today, like 4 months later, you want to go back and know, what did you do? But just as importantly, why did you choose this? As a team, what were the decision-making process? Like, what criteria did you put down, and what satisfied that criteria and what did not? And so this is what an engineering notebook can do for you. So you're going to, sketch things out. You don't have to be a perfect artist or no CAD, but you can sketch a box. You can sketch your designs, use specific measurements and dimensions, and make sure that you're as specific as you can, especially if you change your design, adjust your engineering notebook to reflect what you finally built. So the test results should be recorded in the engineering notebook along with, what happened and then why you chose one design over the other. Show your work. Here's examples of some engineering notebooks. And then finally, I want to make sure that you come up with a good test. And so this is something that as a class and with your teacher, come up with some creative ways to test your box. But again, it should be repeatable and measurable. There's a couple different examples here of a vibration shake or impact from a pendulum swing. You may come up with some really, really cool ideas. That's the fun part of this lab, I think. Last but not least, who's got the best box? So how do you decide this? Well, if you look on the left-hand side, you'll see overall score. And then you'll see intactness score divided by mass and volume. Intactness score is in that chart there. And you'll see if you have a perfect chip at the end of all of this, it's 100 points. And then slightly damaged. That may be something that your class has to interpret. What does that mean to be slightly cracked? And you can see that's 50 points, and then you go on down the line. Now, what do you do with these point values? Well, look on the right-hand side. Let's say you have a perfect chip, so you got a score of 100. The box plus everything in it is 0.256 kilograms. Now the volume you're going to have to measure. Make sure you do these measurements before you start testing the box, because the box can become damaged and more than likely will. So make sure that you can make these measurements before you test it. You're going to measure in centimeters. So that cc is centimeters cubed. And so measure each dimension in centimeters, multiply those things together. And in this case, we'll assume it's 250. So if you look at the overall score, step 4 there, you get a score of 1.56. Okay. That's great, but it's all relative to the rest of your class. There's one last important thing I want you to consider. The sustainability factor. Once again, it's not always what you do, but how you do it. And so if you look at step 7 there, you'll see that you need to divide your overall score by a sustainability factor. Notice that if you're paper-based, something very recyclable and very friendly to the environment in terms of waste, you divide by 1, so your score doesn't change. But if you're using something like foam or plastic, something that can end up in landfills and may not be as environmentally sustainable as others, you divide by 2. And so that can change your score significantly. So this is your score, and I hope you have a lot of fun with this lab. There's a lot of different designs that can be out there, so be creative, have fun.